Combination circuit, introductory question. Combination circuits are a little bit more tricky. What we have to look at is the paths that the electrons can take. So if we look here using conventional current, we notice that the positive is here, going down, and then it will split into two as the current flows through the circuit. Through here, it will come back together and travel through this ammeter again at the same current that was here. So we have a movement of the current splitting into two. Looking at these two resistors, one 10 ohm and one 20 ohm, we would posit that more current would run through the 10 ohm because it offers less resistance than runs through the 20 ohm, which offers more resistance. Therefore, all the current here would be slowed down by this resistor, and then it splits up again here, and again more current would run through the 10 ohm resistor than the 20 ohm resistor. Finally, the current comes back together right here and goes through the ammeter and then ends up here. Now, to solve this problem, one of the things we notice right away is that we have 4.5 amps running through this part of the circuit. That would mean anywhere where we have only a single path, which includes this ammeter down here, there would be 4.5 amps running through here. So we could answer I3 already. It has to be 4.5 amps with no calculation. Now, the other issue we have to deal with is what's happening through these two locations. Really, what it is here is just going to be a splitting of the current. So if I have 4.5 amps, and there is 30 ohms of total resistance in here, we can just sort of see by ratios which path would offer the most current. So if I take 4.5 amps and I multiply that by, we have a total of 30 ohms here, and one of them is 10, basically by 1/3, we will find the current for here. This calculation results in 1.5 amps. This indicates that 1.5 amps would run through the 20 ohm resistor. So therefore the current at I4, this one is I4 here, would be 1.5 amps. Looking over here, we notice that it's asking for the current through the 20 ohm resistor as well here. Because this is working the same way, this must be the same. So therefore I2 should also reach 1.5 amps. We've got a calculation here for R3. Now to find out R3 is, we know that we've got 90 amps running through here. 90 volts running through here and 4.5 amps. So we can find the resistance total. The resistance total would be the total voltage divided by the total current. The total resistance by calculating 90 volts divided by 4.5 amps is equal to 20 ohms. Therefore, we know that this plus this plus this have to equal up to 20 ohms. So I know that the resistance total will be the resistance of this section, so I'll call this R1, plus this section, which I'll call R2, plus R3. Now R1 and R2 will be the same because they have the same resistances here. So what I have to do is calculate the resistance for this section, so this one, so I'm going to add up the 1/10 plus 1/20. And when I calculate RT, the answer is 6.7 ohms. Because that was the same here, I know that R1 and R2 are the same, so RT was 20 ohms is equal to 6.7 ohms plus 6.7 ohms plus R3. When we do the math here, we find that the resistance through R3 is 6.6 ohms. So R3 is 6.6 ohms.